Welcome to myprojectbazaar.com. Our product title is Voltage Profile Improvement using Static Wire Compensator and Thyristor Control Voltage Regulator. Let us see about the abstract of our product. The voltage level of the system changes when there is change in load, and the drop in the load voltage leads to an increased demand for the reactive power that, if not met by the power system, leads to a further decline in the bus voltage. This decline eventually leads to a progressive rapid decline of voltage at the location, which may have a cascading effects on neighboring regions that causes voltage collapse. In this proposed system, facts controllers such as static wire compensator, that is commonly called as SVC, and thyristor controlled voltage regulator, that is commonly called as TCVR, are used to maintain the voltage within the limits. SVC will either supply the reactive power or extract the reactive power, and the DCVR will inject in series voltage at the load end. So as to avoid voltage collapse, smooth variations of reactive power is possible by controlling the firing angle of the thyristors. Static wire compensator and thyristor control voltage regulator are developed in tested IEEE disk system 14 bus system, and the output are given. In this implementation is done in MATLAB Simulink environment. This flow basis only we did, and also corresponding output waveform only here we presented. And also the overall process using of facts controller, the output efficiency and TST will be decreased and our efficiency will be increased. Next we see about the flow diagram of our product. In this flow diagram, the main source is a distribution generator. Distribution generator is fed to the power grid through a distributed bus. In the distributed bus is controlled by using of fact devices. In this power grid is fed to a load. The load may be a linear or non-linear or balanced or unbalanced load. Overall, the distributed generator is using of facts devices, then transmitted is very efficiently, and also the power factor will maintain the unity. And also in the power grid side, the major power factor correction is a major problem. So due to that, we implemented of fact devices that can be obtained by using of that kind of devices. Generally, the voltage control action of the SVC, that means static wire compensator, can be explained through a simplified block representation of the SVC and the power system. The power system is modeled as an equivalent voltage source Vs being behind equivalent system impedance Xs as viewed from the SVC terminals. The system impedance Xs indeed corresponds to the short circuit MVA at the SVC bus, and is obtained is X suffix S is equal to V suffix B square and S. The basic concept of voltage regulation is the addition of an appropriate in base component to the prevailing terminal bus voltage in order to change its magnitude to the value specified. Thus, voltage regulation could theoretically be achieved by a synchronous in base voltage source with controllable amplitude plus or minus del V in series with the AC system and the regulated terminal. TCVR is considered as the common voltage regulator. It is able to smoothly vary voltage magnitude with a tap changing in the control range. The tap ratio is connected in a series impedance of the distribution line. The DCVR operates by inserting a in-phase voltage to the main bus voltage. So as to change its magnitude, it is modeled by an ideal tap change transformer in series with the branch. Its value depends on the main bus voltage magnitude Vp of the line in which the device is located, the additional voltage in the range. Next we see about the running process of our product. In this proposed implementation, we implemented three kind of process in the MATLAB Simulink environment. First, open the MATLAB main window. After that, we creating a new model file. Then we open the IEEE 14 bus system and 15 bus system. In 14 bus system, we implemented two kind of process. One is the TCVR, another one SVC. SVC is the static voltage controller, TCVR is thyristor control voltage reactor. So those kind of SVC and TCVR are the fact devices. This devices is used to compensate the real and reactive power in the power system. So using of that we can compensate the real and reactive power. So we can improve the power factor in the power system distribution sites. So in the IEEE 14 bus system we are arranging that elements from the Simulink library browser. In the Simulink library browser we using two kind of toolboxes. One is SimPower system toolbox, another one commonly used toolbox. From that toolbox we getting the elements and arranging that elements as per the given flow diagram. After that we arranging that, click the run icon. After clicking that, the output simulation will be starts to run. When the simulation will entered, we open the scope on corresponding output waveform will shown. Then this is the Simulink profile report summary. So in this Simulink browser, we what is the clock speed, what is the clock precision, and number of clock methods, and also total recorded time and overall model methods are shown. And next one is the output of DCVR voltage, and this is the output DCVR current waveform. And next one is the output voltage waveform for TCVR in each base. And this is the load flow analysis from using of load flow measurements. So we using which type of buses in between the buses, swing or PQ or PV or which buses. So that are all mentioned in the bus ID and bus type. Then that base buses have how much base kVA and that reference voltage what is, and the angle of bases, and also real and reactive powers all are given, and also corresponding QLF are given. So the frequencies changes and corresponding output will be changes. Thank you for watching this video.